So having understood the value of limiting percentage of tensile steel, let us go to another topic. This topic is only for gap. What I mean to say is this topic is not there in the syllabus, but I felt that this topic was important to be known by the students who intend becoming the RCC consultants. We need to understand something called as lateral stability. Now what is lateral stability? Whenever we have the beams, sometimes if the length of the beam, the span of the beam is too large, the beam depth or the beam width is too slender, the beam could buckle, the beam could bend due to loading. Now when it is buckling not as deflection, vertical deflection, but buckling as in horizontal deflection. The beam is there, it is loaded, but horizontally it buckles, horizontally it bends. Now this we need to prevent, because horizontal bending can give rise to the other types of stresses. Now that is called as the lateral stability. We need to see that laterally, that is sideways, the beam is stable. Now in order to have the beam stable laterally, there is something called as slenderness limit for beams, so that they are laterally stable. Now what does the clause say? The clause in IS 456-2000 is 23.3. The clause goes this way: a simply supported or continuous beam shall be so proportioned that the clear distance between the lateral restraints, between the lateral supports, one end of the support to the other support, the clear distance between the lateral supports don't exceed 60 times the width or 250 b square upon d, whichever is less, where d is the effective depth of the beam and b is the breadth of the compression phase midway between the lateral restraints. So b, we can for all practical purposes assume that it is the width of the beam and small d the effective depth. So if it is a simply supported beam or a continuous beam, the condition is the span from one restraint to another should not be greater than 60 times the width or 250 b square upon d, whichever is less. Now let us look at for the condition for a cantilever. For a cantilever, the clear distance from the free end of the cantilever to the lateral restraint, that means where it is supported, shall not exceed 25b or 100b square upon d, whichever is less. So they have given us the conditions for simply supported, continuous, as well as cantilever or overhang. So both the conditions are there. I think the best part is solve some examples. When we solve the examples, the things will be clear. But please remember, this portion, this part of slenderness limits for lateral stability is not there in the syllabus. It is only to cover gap. What is not covered in syllabus but which is there in the code, we are trying to cover that portion for you. Now an example. Example is a RCC beam 300 by 500 mm is simply supported over a clear span of 5 meters. So obviously the lateral restraints are 5 meters. The beam is reinforced with 3 bars of 16 mm diameter. The clear cover of the beam is 30 mm. Check the lateral stability of the beam. So let us go to the solution. Given, so whatever data is there given, let us check that part. So given the lateral restraints span is given to be 5 meters, I've written it in mm. The width is 300 mm, overall depth is given to be 500 mm, the steel is given as 3 bars of 16 mm diameter, clear cover is 30 mm. So now first we will have to find the effective depth. Effective depth is capital D, that is overall D, minus the effective cover. So effective depth is 550 minus 30 plus bar diameter half, so 30 plus 16 upon 2, so D is 550 minus 30 plus 8, 38. 550 minus 38 is 512 mm. Now having got the effective depth, let us look at the criteria for lateral stability. First criteria, since it is simply supported, first criteria is 60 times B. So 60 times the width of the beam, that is 60 times 300, that is coming to 18,000 mm. Second criteria is 250 b square upon d. So 250 into my b is 300, so 300 square upon 512, that's the effective depth. This value comes to 43945, which is the one which is smaller between the two, lesser between the two, 18,000 or 43,945. We get the lesser one as 18,000. So clear span should be less than lesser of 18,000 or this. So it should be less than 18,000 or 43,945. So 5,000 mm should be less than 18,000 mm. Yes, 5,000 is less than 18,000, so it is satisfactory. That means laterally this beam is stable. It is not going to buckle under the loads. So that is how we understand the lateral stability. Now this was the check for lateral stability for a simply supported beam. Let us check the lateral stability for another beam. Let us take an example of a cantilever. A RC continuous beam 300 mm by 550 mm is supported on 300 mm by 300 mm columns and has an overhang or a cantilever, overhanging portion 4 meters long. The overhang is reinforced with 2 bars of 16 mm diameter. The clear cover of the beam is 40 mm. Check the lateral stability of the overhang, whether it is really stable. The unsupported length over there, one restraint on one side, free hand on the other side, is given to be 4 meters. The width is 300 mm. The overall depth is 550 mm. Area of steel is 2 bars of 16 mm diameter. Clear cover is 40 mm. So given cantilever beam, so we are going ahead with finding the effective depth. Effective depth is capital D, that is overall depth, minus the effective cover. So effective depth is, overall depth is 550 mm minus, this becomes the nominal cover plus half the diameter. Nominal cover is given to be 40 mm and half the diameter 16 by 2. So 550 minus 48, so effective depth comes to 502 mm. Now let us look at the two criteria. Criteria for lateral stability for a cantilever. First one, 25 times width. So 25 times 300, where 300 is the width. So that comes to 7,500 mm. Second criteria is 100 b square upon d. So it is 100 into 300 square upon 502. So this comes to 17,928. Now the criteria is clear span should be less than, lesser of this and this. 7,500 and 17,928, which is less, 7,500. But our clear span is even lesser than that, 4,000 mm is less than 7,500, so it is satisfactory. Our check for lateral stability is satisfied. This is how we give the check for lateral stability. Though understand that most of the times check for lateral stability will come satisfactory. There may be one off case when the loading is heavy, the span is too large, that we are finding that there is a question of lateral stability. At that time we need to take care. We need to either increase the width or the depth, whatever as the case may be, in order to see that the lateral stability check is satisfied. This is one of the most important checks. With this we come to the end of unit 2, that is the singly reinforced beams. Thank you.